Welcome everybody to this new episode of CCIR's Student Spotlight. With me today, it is our pleasure to have Hasika Oggi, current high school students from Branham High School in California. During her time at CCIR, Hasika was a student in Dr. Zarkin's computational genetics class. And for her research project at CCIR, Hasika focused mostly on antibacterial resistance in MRSA. She's going to tell us a lot more about her research project and her journey here at CCIR. But first of all, I want to just say, welcome, Hasika, to this podcast.
Thank you for having me. It's an absolute pleasure to be here.
So just to begin, Hasika, maybe we can talk a little bit about how you came to CCIR. So what in the first place motivated you to start looking into potentially doing some research in your free time?
So I'm someone who wants to major in biology. And so I was like, well, research would be a really good opportunity for me to gain a little bit more of clinical experience. But obviously, when I started high school, it was during the pandemic. And so I didn't really have that many opportunities to do in-lab research like I wanted to. And so when I was researching various research opportunities in junior, senior year, I came across CCIR. And I thought that it would be a great opportunity for me to gain a little more experience than what I had done in previous summer programs. One of the biggest things that drew me to CCIR was the fact that I could actually generate my own results and my own data and analyze it and just really go through the process of researching and writing a paper, which I felt like that would be really useful to have that experience. I was really drawn by the fact that I could just create my own research project and actually contribute to the scientific literature surrounding a topic. And once I looked at the courses offered by CCIR, I was instantly convinced that it was right for me.
Nice. So tell me a little bit about, I guess, as you were looking at the course catalog, how you eventually came to be attracted to specifically computational genetics and these sorts of topics.
For sure. So I've always been really interested in biology, anatomy, a little bit of genetics from a really young age. But over the summer before senior year, I started to delve a little deeper into biology and its various niches. And that began with looking a little further into antibiotic resistance, drug targets, and drug discovery, because I had visited my family in India really recently. And so we went to see a leper colony. And so my heart really went out to those people. And I thought I decided to do a little bit of research regarding leprosy. And so that just turned into an interest about antibiotic resistance for chronic bacterial infections and various drug targets. So when I saw the computational genetics and drug discovery course at CCIR, I was like, this is for me, because it has to do with infectious diseases and drug discovery. So I decided to go with it. And since my mom works in bioinformatics, I thought it would be really interesting to also discuss a little bit with her some of the findings that I had. So
That's awesome. So I'm curious to hear a little bit more about your actual experience here at CCIR. So doing research, especially at CCIR, is often for a lot of students quite challenging. It's quite unlike what they're doing sort of in their own high school context. How did you sort of initially find the pace and the sort of teaching style of CCIR, working with Dr. Zarkin and so on?
I really enjoyed it. I thought the beginning was really nice and easy. It was easing me into the course a little bit with things that I didn't know and some things that I did know. So it was really helpful to have the lectures begin with something that was just a very solid foundation for everyone to learn about. So we started learning about what is a cell? What's the difference between an animal and a plant cell? And things like that. And then we built off that knowledge later on. And so I found that was really, really helpful, because as someone who hasn't conducted research a lot, especially in the field of biology, I've studied, but I haven't done any actual research. It was really helpful for me to have that base knowledge and then build off of that as I, in tandem do my research project. So.
Mm-hmm. That's fantastic. And tell me more about sort of your experience working with Dr. Zarkin in particular. Not to mention, we should probably also mention here your TA, whose name is?
Dr. Matuszewska.
Okay, excellent. So tell me a little bit about sort of your experience working with both of them. I take it are current scientists, working scientists. Zarkan is a lab leader in Cambridge. What was that experience like, working with sort of people at this level of, let's say, expertise and depth?
So working with Dr. Zarkin was really helpful. Like I mentioned, I haven't had a lot of experience in research, especially in writing a research paper. So the outlines and the guidance that he gave us was extremely helpful. It kind of pointed me in the right direction when I was unsure about where I should, like what I should do. Like I said earlier, the lectures were really easy for us to follow along with. And he always made sure that we were understanding the concepts that were presented to us, doing little knowledge checks or just, asking questions like, do you understand this? He incorporated a lot of exercises for us to do as homework throughout the course so that we would be a lot better prepared when we were conducting our own research with the same tools. And there were a lot of demonstrations, and I really remember a fun game regarding the whole process of drug discovery to drug delivery. So all of those were really, really helpful. And then working with the TA, a really helpful aspect of CCIR was the one-on-one office hours. Sometimes I wasn't able to make it to the TA sessions, but my TA was super accommodating. And so I always found a really valuable resource in those office hours. She was able to give me a lot more personalized guidance because Dr. Zarkin was focused on teaching us the concepts. So if I had any questions specifically regarding my project, I could always ask her and know that she would have at least some sort of advice to give me.
And now that we've sort of talked about your teacher and your TA, I think the last thing that's always that I'm always interested in when I'm talking to former students of the Future Scholar Program is the experience of working with other kids. So one of the unique things about CCIR is that it does bring together kids who are in sophomore, junior year of high school who are choosing to spend their free time over the summer to work on something like computational genetics. So what was that like, sort of working with these other students who, like yourself, were sort of into learning more about biology and working on a research project in their free time?
Yeah. So the peer-to-peer aspect of the program was really nice because each of us got to learn a little bit more about each other's projects because we would be giving presentations on what we had finished so far or what we intended our project to be and things like that. And so each of us were able to expand our own knowledge about MRSA, even if our project didn't really relate to one another in that certain aspect. But also if we ever had another question that we remembered after our TA session was over, or after the lecture session was over, we could always reach out to one another and we never feel very uncomfortable or shy about reaching out. So there was a strong sense of unity between all the peers, which I really appreciated because it felt like I didn't have to worry about oh, well, if I forgot to ask this question, do I have to wait a whole week to get an answer now? So that was really nice.
Yeah, so I think at this point we should talk a little bit about your own project. In broad strokes, can you just first tell everybody what your project was about and maybe how you initially arrived at this as your research topic?
Yeah. So my paper is titled Investigation of 6 Vulnerable Strains of MRSA, High Areas of Occurrence for MRSA, and Protein Structure and Function Variants for the BLASI gene. That's a really long title, but it actually came from my results. So what my paper actually looks at is 50 different strains of MRSA and 6 different antibiotics and the resistance that each strain confers. And I also briefly discussed the variance between the different primary genetic databases and offer some practical applications of the results that I've analyzed, especially regarding knowledge that doctors and scientists have when it comes to treating certain MRSA strains with certain antibiotics. So I kind of decided, I actually didn't really decide that I would be doing antibiotic resistance with 50 strains of MRSA and the various antibiotics that I chose until much later in the course. When I first started, I was like, okay, I'm just going to talk about antibiotic resistance and we're just going to do a nice review paper about the various antibiotics. And then when I was going through the lecture sessions and talking with my TA, I started brainstorming different topics because I found that I was actually interested in generating my own data and seeing what I could draw from that. And so I decided that I would actually do a research project regarding different antibiotics and multiple strains of MRSA. And so I kind of wanted to see what patterns I could draw from the metadata and from the results that I get from these strains, because then you can kind of understand and apply that result to a bigger population in terms of treatments that can be needed for MRSA.
For those of us who are less well educated, can you explain what MRSA is?
Right. So MRSA is also known as methicillin-resistant Staphylococcus aureus. It's a bacterial infection that is quickly developing resistance to many antibiotics like methicillin, penicillin, beta-lactam antibiotics, and more. And it causes a lot of infections, especially in the elderly and people who are athletes or in the military and work in like those close confined quarters. And it can be fatal in some cases if it's not diagnosed and treated properly. And MRSA incidence has declined in some regions, but especially in East Asia, it's a clinical threat due to its high level of resistance to modern antibiotics.
Mm-hmm. And so this, can you sort of elaborate now a little bit on, let's say, the practical upshot of your research and sort of research in your area, sort of given that the increased sort of antibacterial resistance of this particular strain, what sorts of contributions were you looking to make within the field or with your own work?
Right. So what I was hoping to do in making this project is that by looking at the metadata from all my various strains and then also looking at their resistance, for example, if I got like 5 strains from East Asia and then all of them were resistant to penicillin, I could probably apply that information to a bit of a larger population and say, okay, if you find a strain that's from East Asia, most likely it will be resistant to penicillin, so don't use that. And in that case, I think that would be really helpful for doctors and scientists, because when they are treating MRSA, they're probably dosing their patients with just a wide combination of antibiotics using multi-drug therapy and hoping, that at least one of them might be helpful and the bacteria might be not as resistant or more vulnerable to that antibiotic. So in doing this project, I kind of wanted to give a more concrete foundation for doctors and scientists to look at and be like, okay, so this specific strain of MRSA is resistant to these, but it's really vulnerable to a beta-lactam antibiotic. So we should use that when we're treating the patient. And then that way it's also easier, not only on the doctors, but also on the patient who doesn't have to come back to the hospital or stay in the hospital for an extended amount of time while they're waiting to see did the antibiotic work or not.
So one thing I'm quite interested here to hear more about is, given the way you've traced how your research project developed, at first you were just thinking of doing sort of a lit review, and then you realized you wanted to work on data. And then you said earlier that the final title of your paper came from the findings of your research rather than going in specific hypothesis and sort of trying to prove your hypothesis. Tell me about sort of this journey of, it really does sound like your project and had much more of the structure of, let's say, a riddle, where the solution to your problem wasn't clear until or even what your problem wasn't clear until you've sort of arrived at the end of the journey. Tell me a little bit about the how you went through and thinking about your project and what that experience was like.
Sure. So when I first decided, okay, I'm going to look at 6 different antibiotics and 50 strains of MRSA, I was like, I can do this. This is really easy. And so I started downloading all my strains and getting all the metadata for all of them and then documenting all of it. And it took forever. But I was finally able to finish that. And then I kind of got stuck because for me, I'm not the greatest with computer science. And so using the bioinformatics tools took me a little bit of time to get used to them and understand, okay, this is how Professor Zarkin showed us we need to use these, but I do have to change it a little bit to adapt what my results are going to show and like how I want to generate my own results. So that took a little bit of time for me. But in doing so, I was also able to realize, oh, this is really interesting. When I'm downloading like various sets of results, I'm analyzing the different patterns that come from those. And so part of the title of my paper is 6 vulnerable strains of MRSA. And so when I was looking through my results, something that was really interesting to me is that there were consistently 6 different strains, the same strains every single time, that didn't show any resistance to any of the antibiotics. And so I thought that was really strange because MRSA is at least resistant to methicillin, but that wasn't resistant to methicillin at all. And so I thought that was really interesting. And so when I went a little further into the literature, I found out that this was like a special kind of bacteria where you could detach its plasmids and then make itself vulnerable until the antibiotics came into the body, and then it would become resistant for like a short period of time, and then it would release the plasmids, and then it would be vulnerable again. And so when I started doing my discussion and looking at all these various things, I found out that the results of my project weren't what I had originally intended to do, in that I did want to find something that was very specific for doctors to use. And I did find that, but I also found a lot of other things that I was like, this is really interesting, and I'd like to expand on these a little more as well. So, yeah.
That's really cool. I think now I just want to sort of shift gears and talk a little bit about this process of ultimately writing your paper. What were some of the initial challenges that you faced? How has this differed, let's say, from your experience of writing lab reports or essays for English class?
Right. So the first thing that like jumped out to me when I was writing this is that I had to be extremely specific. And I couldn't just go and say, I use the BLAST software to do XYZ. I had to say, I use the BLAST software version, whatever, to do XYZ on this date. And so that made me go back through my paper over and over because I had to do so many revisions, checking to make sure that I did the software updates and everything like that. So that was something that really stood out to me, is that it's really specific. You have to document everything really properly. I think another thing that stood out to me was the fact that research papers can get really long if you don't concise them and tell your information in the most direct way possible. I remember my first draft was like 25 pages long or 30 pages long, not counting the bibliography. And so I sat down with my TA and I was like, okay, how can we shorten this? What can we cut out? What can we leave? So I think something that was really important throughout the whole writing a paper process was understanding what's really important, because sometimes you can just put a lot of fluff in the paper and then it'll look like it has substance, but you know, if you really read it, is there anything important that's being conveyed? So it taught me the importance of being really concise but also direct.
Yeah, so I think at this stage I want to take a couple steps back and start sort of begin reflecting on the whole process. So you said earlier that part of the interest in joining the program was that you were interested in biology and you wanted to learn a little bit more about what that actually means, what doing research is actually like. At sort of a high level, sort of looking back now, what have you learned, and how has this shaped your understanding of what doing science or doing biology means?
I think this is really interesting in that I'm really glad I took this course, because it really opened my eyes to the substance of biology that exists. Because originally, if you had asked me like a year before, hey, what are you going to apply for in college? I would have said straight out biology. I wouldn't have said like, I want to go into microbiology, or I want to go into immunology or something, or genetics, something like that. But now that after CCIR and I've gotten all this information about antibacterial resistance, and I guess research is kind of fun. So understanding like, you know, there is that fun part of research. It's opened my eyes to so many things that I could pursue instead of just doing like flat biology, which in and of itself is also really interesting to me. But, you know, being at CCIR has opened my eyes to that. And also it's taught me that technology plays a really big role in medical discoveries and innovations, which I knew, but I didn't really fully comprehend the grasp and like how much technology is so vital for us today. Because without technology, I would not have generated my results at all. So I would probably be working in a lab, and even that requires some sort of technology too. So I realized, it's not just biology that I could go into. I could go into like bioinformatics and things like that, and I would still be interested. So really, this program just like widened my perspective a lot.
So as a wrap-up question, I'm going to ask you what I ask all the other students when I do the student spotlights. And the final question is this. So doing research is hard. There are days when you struggle with the data and when you don't know what exactly to put on your research paper. It's a grueling process. It's not easy work. It takes a lot of time. So understandably, I'm sure a lot of students thinking about doing a research program are probably quite daunted by the prospects of it. As someone who's gone through the process, who's been through the toil, looking back now, what would you tell a student who's, let's say, a little bit anxious, a little bit nervous about embarking on this journey?
I would tell them I completely understand that research can be a little daunting at times. It was for me when I first started this program, and I fell into a lot of pitfalls along the way. There were times when I was like, can I really keep doing this? But eventually I got back up and I kept persevering. I would say that research is an incredibly valuable experience, both in terms of personal growth and career opportunities. It allows you to develop critical thinking skills. You can learn how to conduct experiments. You become an expert in your own field of study. And you discover so many connections between previous knowledge and knowledge that you gain from the research that you conduct. And research in terms of career can be a great addition to your resume. You have that experience. I totally understand that it can be scary to try something new, but I would encourage students to take the leap and give research a chance, because you never know what you're going to discover about yourself and your interests along the way.
That's a fantastic final answer. So with that, Hasika, I just want to say thank you so much for taking your time to do this interview. It was a pleasure talking to you. And I can't wait to hear what other fun and wonderful things you end up doing in research and science.
Thank you again. It was really nice to be here.